Hi everyone! So glad to have you all back for some cool electronics. Let's get started by jumping right into our beer of the day. Today's beer of the day is a triple IPA. It weighs in at 10.2% alcohol. It's made by Flying Monkeys Craft Brewery in Canada. This one's called Sparkle Puff. Pretty cool name for a beer. And the can is pretty cool too. It stood right out in the beer store. It's so bright and like psychedelic looking, it just stood right out on the shelf. I'm not usually a big fan of IPAs. I don't like very hoppy tasting beers, but my friend Rick really wanted me to try this one because it's one of his favorites. After the first sip, I picked up some notes of grapefruit, and then bam, hit me like a brick wall. I was like, whew, there's a ton of hops in this thing. So I was immediately turned off. But I kept on sipping it, and I started noticing more grapefruit and less of a hoppy finish. So maybe it was the alcohol kicking in, and I didn't care anymore. But I think that the initial first sip was kind of a shock to my taste buds. And after I had a few more sips, I adjusted. So I gotta say, overall, I ended up liking the beer. So I'm gonna give it an 8 out of 10. Alright, now that we're through the beer of the day, let's get started with today's project. This one is project number 8 in the Arduino Starter Kit. There's 15 projects in this kit, so we're more than halfway. We're cruising right along. This one's called Digital Hourglass. The main ideas that we want to walk away with at the end of this project are understanding long data types and how to create a timer. Arduino says that this difficulty level is 3, and it should take about 30 minutes to complete. But through the magic of editing, you're going to get the 10 to 15 minute version. The components that we're going to use for this project are 6 LEDs, 6 220 ohm resistors, 1 10K ohm resistor, 1 tilt switch, and several jumper wires. We're going to go ahead and get started on wiring this. I know I've showed this before in past videos, how to test out a resistor. Of course, you can look at the color bands on the resistor, or you can do what we're doing to make sure you have the correct resistor. Put the negative and positive probes of the voltmeter on either end of the resistor, and which we did. And you can see these are the 220 ohm resistors. You see it says 219.5.4. There's a plus or 5% variance, so we're right in range. And we're going to do this for all of our resistors for this project. But I know I showed it once before. I just wanted to show you guys again. And you can see on the voltmeter the setting we have it set on for ohms. You're probably wondering how this thing is going to work. May sound a little tricky, but really it's pretty simple and straightforward. So far we've been using the delay function to program time intervals on the Arduino. This was handy in our other projects, but not really the function we want to use for a timer. The delay stops all input and output while active. We don't want to do this when tracking time. For example, if you need a 10-second delay every 10 seconds, that would kind of get out of hand pretty quick. A better solution is to use the millis function, M-I-L-L-I-S function. This will allow our Arduino to track time in milliseconds. So milliseconds. In our previous projects, we declared variables as integers, int, which is 16-bit. And values that fell in the range of minus 32,000 to positive 32,000. The problem is, if the Arduino is counting 1,000 times per second with millis, we're going to run out of space very fast. But we can solve this issue by using what's called the long data type. This will hold a 32-bit number between minus 2 billion and positive 2 billion. Now, we're not able to run time backwards to get negative numbers, so the unsigned long is the variable we're going to use to store millis, the millis function. So when a data type is unsigned, it can only be positive. Because of this, we can count even higher. An unsigned long can count up to 4 billion. So that's enough space to store time for about 50 days. So all that being said, it boils down to this. By comparing the millis function to a specific value, we can see if a certain amount of time has passed. We're also going to put a tilt switch in this project so that when we turn our digital hourglass over, it'll start another cycle. Now, the tilt switch is being used as a digital input and works just like a regular switch. It's unique because it detects orientation. There's usually a little metal ball inside that rolls to one side inside the switch, closing the circuit. Alright, we've started wiring up this project. We're maybe almost halfway there. Just wanted to talk a little bit about the process that we're going through to wire this up. As you can see on there, as always, we're wiring up power and ground to the breadboard. We're using the 5 volt. We're going to connect the anode, which is the longer leg, of 6 LEDs to digital pins 2 through 7. We're going to connect the LEDs to ground through 6 220 ohm resistors. Then we're going to connect one lead of the tilt switch to 5 volts and the other to ground. And we're going to do that through a 10k ohm resistor. And we're going to connect the junctions where they meet to digital pin 8. We're going to go ahead and finish wiring this up. As you can see, we're making some pretty good progress on wiring this up. Once we're finished, we'll go over that with you. Just some notes. One thing I thought was, pretty cool. You don't need to have this project connected to your computer after the programming is done for it to work. If you want, you can try and connect a battery to make it portable. The kit comes with a 9-volt battery attachment. And another cool thing is you can have fun. You can be creative. You can design a case for it and put some holes in it for the LEDs to poke through. You can do whatever you like and just play around. We're going to finish up wiring this, and then we're going to work on the code. Alright, we just finished up with the wiring, and we're working on the code. I'm going to try and zoom into the code here so you can look at that. And there's our code. Hope you can see it pretty good. Can we scroll down a little bit on that? Let me see. That's the end. So as you can see, we're going to zoom back over here. We've got it connected to the computer, and we're going to run it, and in 10 minutes we should see an LED popped up. So anyways, now that we connected everything and programmed it properly, we should see an LED light every 10 minutes until every LED is lit in 1 hour, because there's 6 of them. So 10 minutes, 10 minutes, 10 minutes, 6 of them. We're going to have all the LEDs lit. After an hour, we can flip it over. All the LEDs should go out, and the cycle should restart. But that tilt switch is pretty loose on there, just so you know. When you turn this thing over, kind of grab the board by the sides and get a finger over the top of that tilt switch. It's going to fall right out. Maybe you can bend the pins a little bit to try and get the stay in better, make them a little wider, and then flip the board over to see if you did it right, and then flip it back right side up, and all the LEDs should go out, and then every 10 minutes they'll light up again. So if you want to do some extra fun with this thing, you could maybe try wiring wire a buzzer up to it that it can go off at the 1 hour mark. You can see if you can get the LEDs to blink for the hour indicator, or whatever you want to do. There's probably so many creative things that you can do with this project. Alright, as you can see, 10 minutes went by, and our first LED lit up. Let's see what happens in 10 more minutes. And there we go. We've got 2 lights on. It's been 20 minutes. So let's see if that third one lights. So far, so good. And there we have the third LED. So that's a half an hour. And I'm actually timing this on my cell phone every 10 minutes for an LED. And I got to say, it's just perfectly accurate. So in 10 more minutes, we'll see if the next one lights up. And now we have number 4 LED lit. So we got 35 minutes on our timer. And again, perfectly 10 minutes, right on the nose. And there's the 5th light. So we're up to 50 minutes. I think the last one I said 35 minutes. It should have been 40 minutes. Maybe I didn't. So there we go. We got one more to go, and it'll be an hour. And there we have it. There's the 6 LED all lit up. So we have all 6 of them. The project was a success. It was pretty fun. You know, like I said, if you want to play around and add a battery pack to this thing, a 9-volt battery, or you know, maybe try and hook a buzzer up so when the 6th light goes off for the hour, you have a buzzer. You know, you feel free to have fun and play around with those. But that's it for this project. We had a lot of fun, and I hope you did too. Our next project is the 9th one in the Arduino Starter Kit. It's called Motorized Pinwheel. We should be posting that one probably next weekend. Thanks so much for joining us. Please leave your comments below. Make sure to subscribe to Kool Electronics Guy and ring the bell. Thanks. See you next time, and as always, have a few good beers and make some great electronics. Have a good one.